Hi again. This is the third lesson now on exponents, and we are still using scientific notation to simplify. Okay, we are still using scientific notation to simplify. So previously we were just dealing with multiplication, but now we are going to have division or fractions. Okay, so we need to know how to use scientific notation to simplify. Remember, scientific notation is the same as expanded notation, so you expand. Okay, now before you start with the problem, any problem where they say simplify, you must check your bases. If are they all prime numbers? Okay, so this is a prime number, this is a prime number, this is not a prime number, and this is a prime number. So I must start with this one. Okay, break it down to its prime factors. Letter quickly on the side, letter quickly on the side for 6. Okay, 6 2 3 3 1. Okay, so 2 can be written as 2 times 3. So I'm going to come back. Before I start anything, I must convert the 6. Okay, so I will start. Let me see if the space will allow me here. Yes, I will write everything as it is because I only want to change 6. Before I change, you see 6 is to the power 2. So I will write 6 times 6 times 5. Okay, you see that? Maybe let me redo this. Let's expand everything first. Okay, I will take the step out and I will write it here. We will expand everything. Can you still see? Yes, it's clear. You can see. So I will expand 2. We'll have 2 times 2 times 2. It's 3 times. And we'll expand 3. It is 3 times 3. And we will expand 6. It is 6 times 6. And we will expand 5. It is times 5. Okay, now 6 is not a prime number. We must represent it with the product of its prime factors. So we'll continue. We'll write the same at the top because all the bases are prime numbers. Okay, when we come to the bottom, the first 6, it will be 2 times 3. And the second 6, it will also be 2 times 3. You see that? This is for the first 6, this is for the second 6, and then times 5. Okay, now you know we did this previously when we were doing ladder and LCM HCF. 2 and 2, 2 divide 2, and 2 divide another 2, and 2, I don't have another 2 at the bottom. 3 divides 3, and 3 divides 3, and that's it. So what is left at the top is 2. What is left at the bottom is 5. So I have simplified my sum or my problem. You see how we do that? And this you can, let me see if I've done everything correctly. Yes, okay, because this is not the same as the example in your textbook, page 29. It looks similar, but it's not the same. The example on page 29, let me see if I can show you that example. Just hold on for me. This is the example on your page number 29, and this one you start by expanding. You expand 2 to the power 3, and you expand 3 to be 3 to the power 3. This is the difference. Okay, and you expand 6 to the power 2, and you expand 5 to the power 1. But 6 is not a prime number, and we know that 6 is the same as 2 3 3 1. So it's the same as 2 to the power 3. So you're going to have 2 times 2. Everything at the top stays the same. Times 3 times 3 times 3. And at the bottom for the first 6, you have 2 to the power 2 times 3. The second 6, you have 2 times 3. And you have this 5. Okay. Now you go further. 2 divides 2. And 2 divides 2. And I don't have another 2. Then 3 divides 3. This 3 divides 3. And I don't have another 3. So at the top, I'm left with 2 times 3. At the bottom, I'm left with 5. This is the same as 6 over 5. And 6 over 5 can be written as 5 goes into 6 one time, and the remainder is 1, and 5 cannot go into 1, so I will have 1 over 5. This is my answer. This is your exercise or your example on page 29. Example on page 29. Okay, so with that example shown to simplify where you divide, you can do exercise 1.19. Exercise 1.19 to let me see, 1.19 to 1.24. 1.19 to 1.24 on your textbook, page 29. Page 29 in your textbook from exercise 1.19 to exercise 1.24. Thank you.